Okay, good morning, everyone. So today we will begin with a third week of bootcamp, and that is lecture 5. And now the journey will not be easy. It will become difficult because now we are on the techniques that will involve neural networks. And till now, all the techniques that we learned, you were able to literally go and backtrack your error. But now with the neural net involved, there will not be any backtracking and something that you really cannot control except certain parameters. So today we will learn about text embeddings by GloVe and Word2Vec. Okay, let us see what is GloVe and what is Word2Vec. So first of all, let us see what is GloVe. So in the past lecture, we knew all these techniques, right? We had a word and we were able to convert them using one hot encoded bag of words, term frequency and inverse document frequency, and n-grams. We also did a code and we replaced our code with all these functions to generate different embeddings. So if we remember, in the one hot encoded, we had the embeddings where love and cat, they were in a separate row like this, and love and cats, they were not related to each other at all. Like the entire thing till today was based on something called counting statistics, where we were counting how many love word we have, how many cat word we have, whether it is in one hot encoded, even in the bag of words, we were calculating how much I we have, how much love we have, and how much cat we have. That means how many of these words we have in our corpus. And we were marking it. If we had 2 words, we were marking it 2. And it was that simple. That means just count the words in your corpus and you were getting your embeddings out. Same things we were doing with I love cats, but here there was a weightage given to the words depending upon the counting frequency, right? And then with the n-gram, what happened was we had a kind of a sliding window approach. Now, what was happening in the sliding window approach? We were going and taking it bigram, trigram, and again we were calculating that how many bigram or trigram exist in the entire corpus. So this was your learning till now, and it did not involve neural nets. So from now onwards, we will be working on neural nets, except the first concept that we have, but it is also very intense. That is, what is GloVe? Okay. Okay, guys. So what I will hide. Okay, so what is word embedding and what is word embedding by GloVe, right? So we know what is word embedding. Now, what is GloVe and what is Word2Vec? These are the two more advanced models that we use to get word embeddings. Now, here on screen, you see that all these things, as I said, that they had no semantic relationship and they are based on simple counting sequences. Now, on screen, what you see here, that you have a graph like this, where all the words such as man, grandfather, boy, infant, child, girl, woman, adult, they all are plotted in one graph. That means somehow we can say that all these embeddings are represented by these vectors here, and these are vectors which has numbers in a way such that by just translating from, in X direction, from here to here, woman embedding can reach to adult embedding. So that means word embeddings, they are dense vectors that capture the meaning and relationship between the words. And if you can capture the relationship and the meaning between words, then you are really much more closer to understanding the corpus, rather than counting it as we were doing in the previous cases. We were just counting the numbers. Now we are understanding the relationships between them. And once you capture the relationship between them, then you are more close to the entire understanding of the document. Right. So here you see on the screen, we have, all these words which are represented in 2 dimensions, right? Now, if you see here, now, when you have a semantic relationship means that you will have a relationship with king to man and queen to a woman. So this is a kind of relationship you have. So what is the relationship of king to man? There is some kind of thing involved, is royalty between them, right? And what is the relationship of queen to woman? If I make a relationship queen to woman, if I add a royalty to the woman, then I can also make it queen, right? So this concept is a little bit tricky to understand, but we will. And if your words have semantic relationships, then you call them that you have understand the entire document, right? Okay. Now let us see on the screen. So as I told you in the thing, that all the words are represented by dense vectors on a chart in a way that, all these things are vectors. Now, if you see here, if I start giving, right now, just look at this curve here. If I start giving it x-axis, that means this has, my 2, and I don't care about y, 2 comma y1. And here I have 4 comma y2. Here I have 4 comma y3. And here I have 4 comma y4. So I have all these 4 vectors here. Now, how can I'm just doing the translation in x-axis. So you see king here is 4, right? So 2, 4, this should be 6 here, and this should be 8 here. I'm just going in the x-axis, guys. So let us say this is 0, this is 2, this is 4, this is 6, and this is 8. And this is my coordinate x, x1, x2, x3, and x4. So this is 2, 4, 6, 8 here. Now you have king. So king is 6 here. Man is -2, right? And you have something called woman, so which is +4. So 6 minus 2 is 4, plus 4 is equals to 8. So let us see, do we reach 8? Yes, we reach 8. So man, woman, king, queen. So we are going in this direction, x, x, and this is the coordinate we have. So you have reached something called queen. So this is the kind of relationships that we have inside these charts, that how can we navigate from word to another word. And what are the models that are giving that kind of a relationships? Today, we will learn about them. Because in reality, we have with us something called numbers that your computer is processing. When you have your chat GPT working, it is producing the next probable word. And behind it, there is a word embedding of that word that it has learned. So this is what is somehow we are trying to understand that how do we get these kind of relationships. Okay. So now, before that, let us understand the concept of multi-dimensions. So what is multi-dimension? So on the screen, you see multi-dimension means that we have a kind of, a word which is not understood in one dimension, but it will involve n number of properties to it. For example, on screen, you see that we have something called a property called living being, other property called feline, then there's a property called human, then there's a property called gender, then there's a property called royalty, then verb, and then plural. And these are your multi-dimensions, right? These are your 7 multi-dimensions here on screen. And I can, like this, take n dimensions. I can take n number of dimensions and I can add more to it. But right now I have 7 dimensions. And you have on screen, see cat. So there's a score involved to cat. Cat has a score of 0.6 as a living. Feline, I have everyone joining me late today. Okay, very good. So cat has a score of 0.6. Living being. Feline has 0. Cat, how much feline it is? 0.9. Okay. Cat is a living being. Cat is a feline, 0.9. How much human it is? Human, it is only 0.1. Gender, it is, okay, there's a score that, okay, it can be male or female, right? And we are giving it 0.4. Is cat is a royal? No. We are giving it minus 0.7. It is a verb? No, I'm giving minus 0.3. Plural? No, I'm giving it a 0.2. So like this, I have, multiple dimensions and I can fit all these words into it. So look here, kitten has living being, yes, score is high. Feline, score is high. It's a human, no, score is no, negative. Gender, yes, little bit score. Royalty, verb, plural. We are not giving any kind of weightage to these things. And like this, we can also have, criteria. Living in a country, you can give n number of dimensions depending upon the vocabulary you have. And you can give it a dimension, does it, does it have bathroom in it? Why bathroom in it? Now go here, same thing has houses, the same vocabulary. Now for the vocabulary houses, we have a word living being, which is 0.8, the weightage. Feline is 0.4, human minus, gender maybe, they're giving little bit value to the gender. Royalty, no. Verb, we are giving it 0.3 and plural 0.8. So they say it could be a verb, okay, it could be plural. So that means the entire vocabulary that you have, you can give it n number of properties. And here it was a bathroom, and here, yes, house have a bathroom, I was giving it 1. And this is when you have all these numbers connected, you are then finally able to put them in one plot. What the idea behind semantics and the word embedding that have a semantic meaning is that if you have 10,000 words in your vocabulary, or you can say Wikipedia has 10 million words, we should be able to plot all those words in dense vectors, such as we can translate from one vector to another very, very smoothly. That is the entire idea. And to achieve that, you can give n number of dimensions to any word. Other dimensions will be 0 for that word or negative for that word, so that they don't occur together. For example, here on the screen, you see dog, cat, and kitten, they are in the one curve. All these things are man, woman, king, and queen. They are also in one curve, right? And this is, if I want to plot here now cat and kitten in the same curve, maybe it is existing somewhere far, right? It won't be here somewhere, as you see here, houses is here, but somewhere far. So this is where, that is how your computer understands semantics, right? So here word embedding, and we have dimensionally reduced it from 7 to 2 to finally give it a 2D plot. And these are all our 2D plots here on the screen. So if this made sense to anyone, and I am open to questions, this will be slightly difficult understanding. Okay. Now, what is GloVe exactly? GloVe is global vector for word representation. So as you see the word global vector, and that means we are trying to somehow have a vector representation that covers various end dimensions to it. And all the word is represented by dense vectors. And these vectors, they capture the meaning and relationship between the words, right? So this is what GloVe is doing. So for example, what GloVe is based on right now is based on co-occurrence statistics. For example, if you see, what we want to achieve is from the GloVe, a kind of embedding where words like Paris and France are strongly connected, or words like Paris and Japan are less connected, or Paris and banana are totally unrelated. And we want that kind of relationships that should happen, right? Similar, king and queen are related, right? And we want a relationship in which we can tell, Paris is related to France as London is related to England. So this is a kind of understanding that we want to give to our embedding. Now, this was the main idea. Again, we are doing today semantics embedding, the embeddings that have semantic meanings, and we are discussing right now a model called GloVe, right? And GloVe, what it is based on, it is based on co-occurrence statistics, where we are giving meanings to words and where we are defining the relationship between the words. Paris and France, Paris and Japan, they are somehow connected, where Paris and France are more connected, right? And now we will learn in the next slide how this model is working. Okay. Okay, guys. Now you all know these things, and now I think this is last lecture where the understanding would be so much clear. Now I think after your session 3 and 4, it will develop very strongly. And I would say coming 2-3 lectures are very important in the foundation of you to understand neural nets. Right now on screen right now, we have a corpus of sentences. The cat sits on the mat. The dog plays on the mat. The cat and dogs are friends. These are simple corpus of sentences. Now, can we build a vocabulary out of this? So the vocabulary out of this is the cat sits on mat, dog plays, and are friends. So out of this entire corpus, we have taken the vocabulary. So you see the D is repeated so many times, 1, 2, 3, 4, 5, and 6. But this is the cat is repeated 2 times, but in the vocabulary it is 1. Sits once, on once. Then we have mat, right? And dog plays and are friends. So this is kind of, the vocabulary. Now, after this vocabulary, what we are trying to do is we are trying to build a co-occurrence matrix. Now, what is a co-occurrence matrix? How do we build it? Now, in the co-occurrence matrix, you see here, the cat sits on mat, dog plays, and our friends are represented in a row. And this is the same thing is represented in a column. the cat sits on mat, dog plays, and are friends in the row. So this is your column here, and this is the row. And now you start finding that where there is a co-occurrence. So co-occurrence, you see how it is working. The cat. How many times is the cat? The cat together is 2 times, right? Now this is the cat. 2 times here, 2 times here. These sits. There is nothing called these sits together, right? There's nothing called these sits together. 0. There's a 0 to these sits. Now, like this, you are something calculating a co-occurrence matrix, which is a little bit difficult to understand. That how in the entire corpus we can find what is the probability of these 2 words occurring together, right? So what happens is you have the entire Wikipedia, and in which you have lines like this. The cat sits on the mat, the dog plays on the mat, the cat and dogs are friends. Paris and, Paris is the capital of France. London is the capital of England. So it goes on to those words and try to find how many times those words occur together. And after that, it tries to calculate that. And once it knows that how many times those words have occurred together, it tries to give it a number. Now, for that, you have to first of all create a vocabulary. After creating the vocabulary, you have to create this kind of matrix. You will have a row and column. And after that, you have given it a row and column. Then you start counting them, right? Okay, now what happens then? After you count them. Now, conceptually, now you see here, this is the probability of co-occurrence. Now, what I'm trying to do is, guys, I'm trying to see how many I'm trying to now find a relationship. Now you see here, the simple formula is that I'm trying to find how much times the and cat exist together. Or, the and dog exists together. Or R and friends exist together. For that, I have plotted this matrix, and this matrix literally you plot out of the entire Wikipedia. And now you see here, how do you calculate? So I'm trying to calculate the probability of a pair, the cat. So how many times the cat is existing? The cat 2 times, right? And how many is the co-occurrence matrix here is 42. I just added all these numbers. So this is the probability of the and cat is 2 by 42. And then the probability of the and dog, it is also 2 by 42, because the and dog, 2 and if you see here, dog was the 2. So this is the same thing. This is just the matrix. The 2, either you take 2 here or 2 here. This is the dog. Now cat and mat together, cat and mat, they say it has occurred 1. So this is the probability of the cat and mat, right? So now after that, you have calculated this probability. Now guys, this is where the main logic is. You have this probability. This is Pij. These are the individual probabilities, right? And after that, you have this thing here that was the probability of the pair, individual probability. Once you calculate that, that converts into W and Wj, which is your word embedding, right? So, and this is here is a bias. So guys, this is little bit important in a way that you should be able to understand that, this is how your word is converted into numbers. And there are now much more deeper concepts involved. Okay, so this is here the formula finally, log Tij, and you computed it in the last slide, right? Right. So we computed it here. And now what is here on your screen is a smaller example, so it is much more clear to you. So from that bigger thing, we have taken these co-occurrences. Now you have to imagine that this is your small matrix, not the big one. So you can calculate by on your screen here, 2 plus 2, 2 plus 2 plus 2 here, 8 plus 2, 10 times. So this is the total number of your co-occurrences, which will be a denominator, right? And out of that, your D and cat together is appearing once. So D and cat is here, so 2 by 10. Now, word, total co-occurrence of the word D. So the idea is how many times D is occurring with other words. So D here is occurring with other words is 4 times. So that's why we have 4 by 10. Now, what is the probability that cat is occurring multiple times? So cat here is occurring multiple times is 3 times. 2 plus 1 is equals to 3. 3 by 10. So then idea is that out of, where D and cat are occurring 2 times, and totally the is occurring with other words 4 times, wherever cat is occurring with other words 3 times. And then you try to compute this. Now you try to compute this here. And you put this number, you're just putting this in the formula Pij, which is your 0.12. D and J is something 0.12 here. And this is the probability of D and cat here. This is the probability, you saw that. D is probability 0.4, cat is probability here 0.12. So I am just putting 0.12 here. Pi into Pj, right? And now the probability of D cat has the probability here, which was 0.12 by this entire formula becomes 1.67. This entire thing. So this was 0.12 at the denominator and Pij was 0.2. So this is 0.2. So basically 0.2 divided by 0.4 into 0.3. So this becomes here. This becomes here, this formula here. 0.2 into 0.12. This is 1.67, right? So this is, and then you take the log out of it, and then it becomes 0.18. So this is the easiest concept to follow. Tomorrow's class is even much more, much more heavy because you're getting into neural nets. And you're trying to understand how AI works, right? So it's gonna be slightly tricky. So this is how the probability is getting calculated. Again, I am calculating the probability of D cat. What is the probability that D cat is occurring together? Probability of the word D, how many times it occurs with other words? Probability of the word cat, how many times cat occurs with the other? And then I put it into this formula here, where you are simply doing 0.2 into 0.4 at the bottom, which makes it, sorry, 0.4 into 0.3 at the bottom. That makes it 0.12. And this is the D cat here together. D cat is on the numerator 0.1, 0.2. And this together, it becomes to log of 1.67. I hope it is clear to everyone. And like this, you calculate Wi and Wj, right? Okay. Okay, somehow stuck. Okay. Okay. So guys, this is now, it gave us a number here. This entire thing gave us a number, which was 0.18, right? Now this 0.18 is equal to your Wi and Wj, plus bias is something that I should be able to explain more clearly. So tomorrow's lecture will be introducing neural nets to you. And this is a bias. That means when your model doesn't fit accurately, you have little bias there, which tries mathematically to have your left-hand side equation equal to right-hand side equation, and then model tries to fit it. And this is some kind of bias, or you can say a little adjustment that you have to provide, which is fine. But forget the bias for right now. You just say this Wi and Wj, they have a 0.18. And this just tells us the degree of co-occurrence between D and cat with respect to each other, right? And this is where, you will plot these things, cat, D will be here, somewhere the cat will be here. And it has some kind of relationship of 0.18. Now the words like cat and mat, cat and banana, they will have, some kind of relationship between them, which you can compute with number, right? And that you compute with numbers, you're plotting them here. And that one, because cat and mat, they still occur frequently, you will have some kind of relationship with them. But cat and banana, you will have some relationship which would be very weak relationship, right? So this is how your GloVe is working, which is your global vector representation, where you're representing your entire text into your kind of dense vectors, where you can translate from one vector to another vector and compute a relationship between them. So this was the main idea. So what I am right now, let us do a code. Okay. Now, for the code, guys, you have to be doing these codes. Sorry, this is some kind of glitch. Just a second. Sorry, guys. Just a second. Okay. Guys, let's look at the code, and we will run this code here. So what we are doing is we are learning embedding by GloVe. To do that, you will import NumPy and Panda. So guys, whenever you are doing numbers in your notebooks, you will always do NumPy and Panda. These are two very, very important libraries, as I talked about. NumPy is good for you doing your basic computation, and the Pandas is even for little bit advanced. Then you have a library called Seaborn, that is for visualization. And then you have a library called matplotlib as PLT here. That will occur as your, in which you can see plots. And then you have all these four libraries that you generally import in everything. Then you have something called GloVe. And because this is a library already in the Python, and I import something called corpus. So what corpus and GloVe, these are two functions which are in this GloVe library that are doing everything for you. Now here you have this toy set here. Cat sits on the mat, the dog plays on the mat, and cat and dogs are friends. And you can keep on adding it. I will try to add it for you. Now, then you know that this is a clean text. So there's a step that is involved here, that is cleaning of text. And then what you do is, after you clean the text, then you start tokenizing the text. So you will start splitting that text by using, simply sentence.split. This will split this bigger sentence into small tokens, which we will see in the next step, that how they appear. Basically, D will be a separate token, cat will be a separate token, sits will be a separate token, right? And now you have to generate in the step is co-occurrence matrix. So you finally you have your data set, you're tokenizing it, and you're generating a co-occurrence matrix as we saw here, right? There will be the entire vocabulary here, and then it will start giving you the numbers. And here you are generating the co-occurrence matrix, right? And after you generate the co-occurrence matrix, you start to fit it. Fit would mean this is the entire model that is to generate this co-occurrence matrix. So you had the text, you tokenized it, and then you generated the co-occurrence matrix. Now, these are step 1, 2, and 3. These are the important steps. Now, all the other steps are related to visualization, that how you see everything, right? That means you want to see it, in a matrix, you want to see it in the chart, and what. So the important is your data set, you tokenize it, you generate a co-occurrence matrix, right? And after that, you convert this into, your data frame for better visualization. This is not so right now. I mean, you can play with it, but I would not focus a lot on this, to be later. And, it is to be for the later thing. Now you can visualize it as a heat map. So I will just put it on the next slide. How do we visualize everything on the heat map? Now, for the heat map, again, we are using here, I told you that Seaborn is a library to visualize. So sns.heatmap. That will tell you that how this co-occurrence matrix is appearing with the heat, right? This is the heat map. Okay. Now, after you have the heat map, now there's a step that is involved is, guys, you have the dimension here that you can choose. So finally, remember that king, queen, everything, you had certain dimensions, and your dimension is 8 now. Remember that I had a bigger plot there where, I have feline, I had, gender, and I had multi dimensions. And you can go and do the multi dimensions here, right? This is embedding, and we have chosen 8, right? And after that, you just fit it. And once you fit it, then you add, right? So you're fitting it here. And then there's a visualization. That means you are simply playing with the chart. I'm not worried about this. You're playing here, you're playing here. And then you are reducing this multi-dimension to something, your 8 dimension to your steps. And again, there's a visualization. So I will now run the code. But before that, I will give again a small summary. Summary is, you have your data set, you tokenize it. After that, you are using something called corpus.fit. This is an important here. That will make it into a co-occurrence matrix. After corpus.fit, what will you do? You will come here and you will do glove.fit. What is the corpus.fit is doing? Corpus.fit is generating it into this kind of co-occurrence matrix. What is glove.fit is doing? Glove.fit is helping you decide the number of multi-dimensions, that how many dimensions you need. So corpus.fit and glove.fit are the 2 important things. So in the corpus.fit, you will choose something called window size. So window size will tell you that, if you want, for example, in the co-occurrence matrix, you were going here with the next word, the cat sits on the mat, right? If you choose a window size of 2, D is only taking cat. If you choose the window size of 3, then D will take cat as well as sit as well as on. So this is a window size of 3. And like this, so it will have a score that it will consider the cat is sitting next to it, D is sitting next to sit, and then these also sitting next to these. So you can play with this. I will play it for you. So window size could be 2 to 5 or 2, depending upon your corpus, could be 7 as well. And that is how your vocabulary, your embeddings will become larger and larger. Then you will also have a vocabulary size. Then you also have the size of the vocabulary, and then you have the embedding dimensions that you can choose. You can play with it here. So again, data set, tokenize, corpus.fit, glove.fit. In the corpus.fit, you will choose here your co-occurrence matrix, and in the glove.fit, you will choose how many dimensions you want, right? And this is the code about. Okay, now let us do the code. I hope this concept was clear. Guys, you have to go and look at these, lectures again. Then only it will be clear. Why I'm not, just a second, I'm trying to run the code. Okay. Okay, guys. Let us do the code now. Okay. So guys, in the code, so you can begin here with installing GloVe. So you are installing GloVe here, and you are installing Python 3, and you can install this. I can give you this code. Now you start importing all these 5 libraries here: NumPy, Pandas, SNS, PLT, and GloVe. And now you have a data set, which is same data set. You are able to tokenize it in the next step. You are able to tokenize it. After tokenizing it, you are generating a co-occurrence matrix. And let us see how this co-occurrence matrix is changing. So you have a co-occurrence matrix, window size 4. Pay attention here. So window size is 4. So you see here, this is a co-occurrence matrix of window size 4. And literally your matrix is the cat sits on mat, dog plays and are friends. This is your co-occurrence matrix. Now, in the next code for you, I have done a co-occurrence matrix. Let me remove this. Now I have a co-occurrence matrix of window size 2. So you see here how these numbers change. When the window size is 2, it is 2, 1, 2, 2. And when the window size is 4, it changes to 2.311, 2.66 to 2, right? This is how this entire thing is changing. And now this is changing with your co-occurrence matrix. And this is your window size. And you can also take, play here. And if I do here, window size of 6. And I told you the meaning that window size of 6 means now D will calculate probability with cat sits on mat, like it will take 6 neighbors next to it. Now cat will take 6 neighbors next to it till and on will take 6 neighbors to it. So this is how. So concepts a little bit trickier. And this is window size of 6. And you can play with this parameter to change the context size. Right? I have played it, put it 6. Now see what is happening here. It should run. Okay, I did not import here GloVe. Give me a second, guys. Okay, I've imported it. And I have generated now with the window size of 6. You see the number has further changed. I can do it 8. Generally, in the bigger corpus, they do it for 8. And you will take this code and play with the context size. And this corpus.fit is basically changing this thing for you, right? After this thing, corpus.fit, now what you have is, this is all optional here. You are just, you're better looking at it. So it is actually this step, which is giving you this matrix here. This is your co-occurrence matrix, right? And after that, you are visualizing it as a heat map. So this, all these steps is to show you this as a heat map. So heat map is 2.66. The relationship, where is this 2.66? This is the relationship here. 2.4, this is also D and on. Maybe they occur many, many times together. Yes, D on together a lot. It says 2.4, mat. It is giving a heat map. It says D and mat also occurs very much same, a lot with each other. D and cat also, they gave it a very high score, right? And C, 0. It says D and D, they never occur together. So it is giving it a 0 score, right? And similarly, it is giving D and. Okay, we have in a lot of sentences D and together. It is giving it a 0.5, right? So like this, it is giving it this kind of a heat map. And here we had this heat map, and we plotted this heat map here. Now, after this heat map, now I am training them with to generate word embeddings. Now, guys, your word embedding are not simple as 1100. So the word embeddings are very complicated. These are the word embeddings. And here also you can play with a parameter that is a dimension. Depending upon this, if I want, I can just take, 4 dimensions. Or I can take here 10 dimension. You can play. And once you play, your entire code changes. Now you have a 10 dimension. More dimensions you will play. That means more words you will bring it together on one plot. So you see here, this is like all the words which are plotted together in one direction, right? So this is your this thing as a heat map. Okay. And after that, what is happening here is your heat map is generated. Then you are playing with this fitting, you can convert the word embeddings, and now you're just visualizing it, guys. And here, this is what I do here is PCA, that is principal component analysis, that converts from 7 to 2. Remember, I had 7 word embedding here, if you remember, and I was converting it into 2. Since beginning, I had 7, and I was converting it into 2D, right? 7 to 2D, right? Guys, this is important concepts here. And I would see that please go through the recordings again and again to have better idea. And this will convert this from 2 to convert it into 2 dimensions. So overall, this is how you get 3 things. One is your heat map, other is your word embedding, and other is your PCA visualization. Now to summarize this code again, so that it should be very much clear. You have corpus.fit, play here. Rest is visualization. GloVe.fit, play here. You play with the dimensions. You play with the window size. And then at the bottom, you play here with your PCA component here. And this PCA, that will convert into 2 dimensions, right? And this is your 2, which actually converts your word embedding into 2 plot. And you can play here, and this will generate this kind of embeddings for you. This will generate this heat map, word embedding, and this kind of visualization. Now, after that, you see here, when my dimensions here, now my dimensions here were, embedding was 8, right? Versus my embedding was 10. It all came outside, right? All the words came outside. Let us now put it as maybe, embedding as 12. Or, you can put as many as you want. Maybe it doesn't work. More words outside, because what is happening is more dimensions we are giving. It is trying to bring all the words in one chart, right? And that is the idea about GloVe. I hope, we are on time now. With this class was clear. Tomorrow, guys, we will introduce AI to you. I will introduce what is a neural net, how this calculation is done. So these concepts are very trickier. What I do is try to break it for you in a very bite-sized concepts, because if I don't break it into bite-sized concept, you won't be able to understand how things are happening. And these are trickier concepts. So tomorrow, what I will do is I will introduce how your neurons are working, how AI is working. And finally, next week, we will know how transformers are working and how your chat GPT is working. And I think that will be the conceptual part. After that conceptual part is there, then we will work on RAG, agents, and these things, some projects, and that will be at the after your Christmas break. But before your Christmas break, we will try to understand how your chat GPT is working. And to do that, these concepts till now, they will become very, very intensive, because ultimately you are learning AI, that is artificial intelligence. It cannot, it cannot be a simpler concept. Otherwise, you would be able to backtrack everything. But I have broken everything for you in a bite-sized concept. So try to go through these video recordings, make your notes, try to run these toy codes. I think everyone should be able to do right now a code on spam classification using all the 5 kind of word embeddings I have given. If you go to the code of spam classification, to which you will also find the links in the YouTube video recording, go there. When you go at the bottom of the codes, there are also codes done on a very big data set, which will be identical to any application you would build, right? So you have to, keep yourself motivated. Now for few weeks, please try to work on all the concepts at your home as well. Let me know if you have questions. I can answer in the chat. Yes, this concludes the class for today. Yeah. Any questions? So a lot of you asked me about, guys, we will have classes 9th, 10th, 16th, 17th, also 23, 24th. So that would cover, I think, half of the boot camp before Christmas. And then we will have, 2 or 3 weeks break. And then we will continue with the rest of the classes. And rest of the classes would be actual project building classes. Let me know if you have any comments in the chat. I hope you found today's class interesting, and you understood what is GloVe. Tomorrow I will introduce what is word2vec and how is a neuron works. Okay, I don't see any comment in the chat. Guys, then see you tomorrow, same time. Bye-bye.